Hello, everyone, and welcome to another episode of the Futurum Tech Webcast. I'm your host, Ron Westfall, Research Director and Senior Analyst here at Futurum Research. And in this episode, we're going to talk about cloud optics, we're going to talk about AI, and we're going to talk about silicon-driven AI innovation and what Marvell is bringing to the market, and so much more. And joining us today is my friend and distinguished colleague, Nigel Alvarez. Good day, Nigel.
Good day, Ron. Glad to be on.
Right on. It is just that great. And thank you for joining us. And to start, tell us about yourself and how you came to join the Marvell team.
Absolutely. So my name again is Nigel Alvarez, and I lead all our global marketing and business planning. And I joined Marvell about 6 years ago, just as Matt Murphy joined and started the transformation for Marvell. I joined to lead our flash business unit. So I was leading all the SSD controllers and data center initiatives in storage. And about 3 years ago, I moved to a central function to lead our marketing activities, and super excited of all the new technologies we're bringing to the table. And we'll be talking about one of the key innovations we just rolled out.
It's been an amazing journey and so much more. And let's jump in with that and talk about Marvell's Nova offering. I know our audience is keen to know more about Nova.
Yeah, absolutely. So at OFC 2 months ago, early March in San Diego, we announced the industry's first PAM4 DSP for 1.6 terabits per second, enabling 200 gigabits per second wavelengths. That was an industry first. And this continues Marvell's leadership in enabling these PAM4 DSPs, which are the critical engines for cloud data center optical interconnects inside a data center.
And that's an excellent kickoff, Nigel. And I think that triggers a couple of major questions. What impacts will the Nova technology have on cloud providers and their customers? And what are the challenges they are facing out there?
Yeah, so just at the highest level, bandwidth growth inside cloud data centers is growing at a huge CAGR, greater than 40% per year, and continues to grow at that healthy pace as more and more inside the data center, we like to call it east to west, so server to server sharing data. So I like Ron's tweet. I say like, that data has to go back and forth to make sure things that Ron has been talking about and relevant topics gets put on my feed, right? So ton of inside data center type of traffic and bandwidth that is driving the optical interconnects inside the data center. And then on top of the traditional cloud applications, you have this new emerging AI era that has started off. And we're all familiar with ChatGPT that's really taken the world by storm. 1 million users within 5 days and continues to grow at a fast pace is the other big engine that's actually driving optical connectivity roadmaps at a much faster cadence and is actually the big driver for our Nova product.
Yeah, and that's excellent insight. And I think that is definitely something that's an ultra hot topic, AI. Every conversation I've had over the last 2 months has involved that automatically. And so naturally, I would like to know more about what Marvell is doing to stand out in terms of enabling AI and meeting all the emerging AI demands out there in the market.
Absolutely. So as I mentioned a little earlier, we innovate on these optical interconnects. We've been the first to PAM4 technology. So we were the pioneers of this through the Inphi acquisition. So our strategy is to be first to the next speed. And we're at a cadence of actually moving to the next speed or doubling the bandwidth every 2 years. And that enables you to also lower, we have a 30% lower power per bit every generation. And we also have a 30% lower cost for the modules. So we're enabling these cloud data center companies to lower their footprints from a power perspective and from a cost perspective when you're looking at how much data you're moving, right? So as their data movement needs keep increasing, we're lowering the cost to move to those faster speeds. And that's the number one value proposition we're bringing to the table to scale their bandwidth requirements and meet them.
No, I think those are clear differentiators. I think they really jump out. And another thing that leapt out at me with the Nova announcement is that it's the first chip with 200 gig per lambda or wavelength. Can you explain that, provide more insight on that capability?
Absolutely. So today's mainstream, and when I say mainstream, I'm talking still at the bleeding edge AI applications out there. It's 100 gigabits per second per wavelength. And a wavelength is like the light going out of the module. So the speed would be 100 gigabits per second. Nova is enabling 200 gigabits per second. So there's multiple ways you can look at this. You can get the same amount of data in half the time, is one way to look at it, or you can double the amount of data you send in a given period of time, right? So those are the two ways to look at it at the highest level. And I think as AI is driving more and more bandwidth and data movement, they want the faster speeds so they can at least keep their completion times from a training perspective as minimal as possible. Because time is money for these cloud providers. They're looking to rent out their GPUs, rent out their CPUs, so they don't want the interconnect to be the bottleneck. And I can tell you right now, if you look at a traditional server, which is two CPU sockets inside, a NIC is maybe 100 gigabits per second, maybe 200 gigabits per second if you're on one of the leading providers. A GPU bandwidth requirement is 3.6 to 4 terabits per second. Just think about that for a minute. That's like 30 to 40 times more bandwidth required for just one GPU. And guess what? A training set needs more than one GPU. Leading edge clusters by the number one GPU provider out there is 8 GPUs in a cluster. So you times that by 8, now you're looking at 30 terabits per second. So 100 gig or 200 gig to 30 terabits, you're looking at a 200 to 300 expansion of bandwidth. So guess what? You need faster optical interconnects to connect all these things. And it starts with these modules that we enable. Our DSP goes into here and then spits out optical links running at 200 gigabits per second. So really, really innovative stuff, and really driven by the appetite or the need to scale your cloud data centers. And back to your first question, I know rattled here a little bit because I'm super excited, is the 200 gigabits per second actually also reduces the number of lasers you need. So just think about that. Lasers are the number one failing component in a module. So if you're able to cut down the number of lasers by half, because now you're doubling the rate, back to your original question of 200 gig versus 100 gig, your reliability of these modules goes up. And you're able to also reduce the number of fibers. So instead of using maybe 8 fibers to get 800 gigabits per second, now you can use 4 fibers because you have 200 gigabits per second, right? So you can also reduce the number of fibers. So there's so many wins when you move to this 200 gigabits per second, right? So super excited by this innovation that our engineering teams put together, and we're bringing it up with all our leading AI and cloud customers right now.
Yeah, from my perspective, I think those are really standing out. I think it's really, truly a difference with a distinction. And I like that point, Nigel, about in terms of my conversations with the hyperscalers, the cloud providers, real estate is a big deal. It's a big concern. And the data centers that have been built over the last 20 years are, built to have staying power. But now it's becoming more challenging to expand. And I believe this is exactly the type of technology and innovation that's needed to also address that critical concern. What is Marvell doing to address the real estate challenges of the cloud providers out there?
Oh, awesome point, Ron. And I didn't touch upon that when you talked about the 200 gig versus 100 gig. One of the big benefits is instead of now needing, say, 64 modules for a 100 gigabit per second type of architecture, you can now use 32 modules. What that enables you to do is stay at the 1U form factor. And that means you can get 2x the capacity or keep at the same density, right? From a perspective of scaling. And it goes back to your point, is you want to minimize the amount of space you're taking for the connectivity. So this module will help you build a 1U box for the leading edge of 51T switches that are coming out. versus a 2U if you use the 100 gigabit per second type of module. So this does save your real estate from that form factor perspective.
Yeah, I think Nova is definitely introducing some key breakthroughs. And I think this is aligning with developments that many people are discussing in regard to co-packaged silicon and direct drive designs. And from your perspective, Nigel, what are the pros and cons here? What are you seeing in regards to this major area?
Yeah, I think there's a lot of buzz around this linear detect drive type of technology, co-packaged optics. That the technology for those areas, and they introduced it at 100 gigs, so all the cool stuff that Nova's bringing at 200 gig, all that LDD stuff and co-packaged optics is not there today. But let's just say they were there, right? Let's assume they were able to get there. Now, LDD requires a lot of fine tuning, very manual type of work to make it all come together. So when you look at these cloud data center companies, the number one thing they're looking for is reliability. They want uptime, right? They want to make sure their systems are down. This LDD's got a lot of failure potential, right? That's one. Two, they want an ecosystem of suppliers. They want multiple folks to be able to address their needs. They don't want to have one supplier and that's they have all their engineers fine tuning this when something goes wrong. They want to avoid that, back to this reliability. And the biggest thing going forward is they want to move to the faster speeds, right? So the DSP architecture enables you to get to those faster rates at that 18-month to 24-month cadence. So those are some of the fundamental challenges that LDD and co-packaged optics have. Now, with that said, there might be some niche use cases, but for the mainstream high volume use cases, the DSP-based architecture is what our customers are all gravitating towards. And it's really a race to the next bandwidth, which the DSP is solving, right? And that's the big value we're bringing, as well as the big ecosystem of suppliers and multiple sources.
Yeah, from my perspective, Marvell's covering all the bases. You're meeting what exactly is required today, keeping a close eye on LD and CPO and their developments. It could be 2 years before they become more mainstream. And regardless, Marvell's ready. And that, I think, is something that's very important to the customers out there and the prospects out there. And on that positive note, let's shift a bit. Let's talk about something that is different, but I know is very much top of mind in terms of my conversations out there and what the decision makers are keen to know more about, and that is AEC. Nigel, can you tell us more about AEC?
Yeah, so AEC, is another piece of interconnects inside the data center, and it's really mainly server to top of rack. Today, it uses a copper cable, a DAC cable, a direct attached copper cable. So that is usually a sub 3 meters, so up to 3 meters, where your server connects to the top of rack switch. Same phenomena is happening. The speeds are going up in that area, and then electrical cables or copper cables are running out of steam, and they need a DSP to increase or amplify the signal, similar to what you see in the DSP land and optical connectivity is happening in the electrical copper domain. And we're seeing a significant move there as these NICs start to move to 200 gig per lane or 100 gig per lane. They need this active cable. So an active cable, again, is you have this DSP that goes inside the module that connects between the 2 points. So DSPs on both sides of the cable. So it's different from just connecting any cable. You have to actually have both ends using the same type of modules that plug in for the cable. And I think we're in the early innings of this shift over. But I think as the NICs and GPUs and so on move to 100 gig per lane coming out of their NIC devices or GPU devices, you'll start to see acceleration for AEC type of solutions.
Yeah, we've been talking about AEC for a while, and it's great to see this development. I think it's something that will be a difference maker. And I think, it's addressing the fact that chips are becoming more intricate and that they are more specialized. I anticipate more chips will be built on a customized basis. And in the meantime, the bandwidth has become more commoditized. So this is, I think, really good timing in terms of being able to address, both of those major trends. And with that, let's look at a way to address what is really, I think, important, and that is in terms of the modules that Marvell's bringing to market. What kind of shelf life can we anticipate? How long do you anticipate them making a difference across all these cloud environments, driving AI innovation, enabling all these top priority applications?
Yeah, great question. And I think, taking a step back, I think you've heard us say this in the past. Every cloud is relatively unique. They have all different workloads. They specialize. I could be a search company, I could be a social media company, I could be a platform company, and they all have unique architectures. I think you touched upon that on what teeing this up is they're looking to optimize their infrastructure. So the cadence for all these different rates varies drastically by cloud provider. And I think if we take a step back, AI is driving the faster speeds at a much higher cadence than the network side, traditional network side. And what we're seeing is the life of these DSPs, and again, we started these DSPs over 6 years ago. We're still shipping some of those DSPs in some of these cloud providers because they have different clusters within their data centers, and they're looking to optimize each of those clusters or each of those racks for those workloads they're supporting. So I think it's hard to put a shelf life, but I can just state that I would expect these new products we're announcing will last for the next 5 to 10 years in different pieces of the network. But there is this cadence to keep moving and the treadmill's on, right? That we have to get to 3.2T. So that's what our team's actively working on. And I think one thing to just close out on the AC piece that I didn't touch upon, that too is based on PAM4 technology. So all that great innovation we've been doing in the optical space can be leveraged here. And because these cloud providers have unique requirements, we do cloud optimizations inside these DSPs to address both the optical domain, and we're taking that into the electrical domain. So that's actually another big value prop or differentiator for Marvell, is all the learnings we've been doing in the optical domain is going to be applied into the AEC side of things, and a lot of cloud optimized silicon around that as well.
Yeah, I believe that's good news for the ecosystem. And I think in terms of wrapping up, I think an important question that, take away for the audience out there, Nigel, is why Marvell when it comes to AI? What is the difference that Marvell is making in terms of making sure the decision makers out there have the confidence to meet the unique and distinct demands of AI?
Yeah, and I think thanks for that question, Ron, because I think right now everyone talks about GPUs, TPUs.
Mm-hmm.
Now, the reality is those GPUs, TPUs, and AI accelerators, they need interconnects, right? It goes back to these training sets that it involves more than just one device. These are really clustered together. And the real bottleneck starting to emerge is the data movement between these devices. And that's where Marvell is innovating with these devices we're talking about today. And not only that, they're looking to optimize those AI accelerator devices. And that's another piece of our strategy. We've been innovating at the platform level. Just last week, we announced this 3 nanometer platform, right? All our building blocks around 3 nanometer. That 3 nanometer technology is not going to only be used in ASICs, it's going to be used in our DSPs, it's going to be used in our switches. So we're bringing this whole platform level together, and it's really going to enable these cloud providers to partner more closely with Marvell, not only on the interconnects, which is a big problem right now, but also on taking their AI engines and optimizing for their emerging workloads, right? Because they have their own internal AI workloads, and then they have their AI as a service type of workloads, and they have different requirements. And Marvell is partnering with these companies, starting from the interconnect side and moving into the cloud optimized silicon pieces as well as in the switching fabrics, right? So a lot of capabilities when you start to innovate and invest at the platform level. And we have a great partner with TSMC 3 nanometer that we're on this treadmill with them. We introduced those building blocks a couple of weeks ago, and we continue to advance that. And that's going to be the big piece that you'll hear from us in the near future of all these new products around 3 nanometer. Both some will be cloud optimized that we can't disclose the specifics, and some will be standard products like the Nova PAM4 DSP type of products. Super excited and thrilled to have the opportunity to work with these cloud companies to advance their infrastructure and really advance society as they're the leading edge of all our infrastructure today.
Yeah, that's excellent. And I'm definitely keeping a close eye on the 3 nanometer breakthrough. I believe that will definitely help Marvell make a strong case for meeting all the demands out there, cloud, AI, you name it. And on that high note, thank you so much, Nigel, for joining us. It's always great to have you on and sharing what Marvell's doing to advance cloud optics and the impact it's having across the entire data center and cloud ecosystems, and not to mention the AI trends out there that we're seeing. Thank you, everyone, and have a great day.